All right, well, process of elimination. There's something flaky going on, so one of the things that could be flaky is maybe the RAM chips. So there were two RAM chips here. So here's one. These are 2114s, very, very popular RAM chip back in the day. These are 1K by 4 bits, so you need two of them for 8 bits wide. So you have 1K of memory here. And so I thought, well, let me pull them out, see if they're good. I don't have any to just swap in and see if it changed at all. They are a bit interesting. They do have ink on them, so I'm not sure why they have ink on them. Denoting pin 1, there's a notch in the part, so I don't know why they have ink on them. That's a little bit suspicious. So anyway, I thought I would test these. Now I have a EEPROM programmer which has memory testing capability in it. So if this was a 6116, it has that built in. Unfortunately, it does not have 2114s in the database, so I can't test them with my EEPROM programmer. So I went online to investigate 2114s, and somebody, I don't have it right in front of me. I'll show you when we get over to the computer. Somebody actually was in the same situation I was in. I think we were repairing some pinball machine or something, some kind of game, and 2114s were in it. So they created a little Arduino-based program to test the ROM. It writes data and reads back data and sees if your RAM is I call it a ROM. Sees if your RAM is operating correctly or not. So I went ahead and downloaded their program, and I put it on this board here. So this is just a Arduino Uno, and there's a piggyback board on it, and I have a little proto board up here. I used this setup back when I was repairing my IMSAI. I was checking a chip out on my IMSAI, and so I still had the board with this little proto thing on it. So I've wired it up here, the pin out, to test these 2114s. And so yeah, let's go over to the computer and I'll show you the program. Show you the program, and we'll run the test and see if these RAMs are any good or not. All right, this is the sketch that somebody wrote, 2114 memory tester. So Danovic, 2018 released. So this is the pinout that you need to hook it up between the Arduino. So this is the pinouts of the chip over here and the pinouts of the Arduino over here. He did have this include statement, which is not necessary in my environment, so I commented that out. That was to make sure that the port ABC or definitions are correct and stuff. Anyway, it works just fine if you have the regular Arduino environment. And basically what it's going to do is it's going to write all zeros to the part and see if they come back 0, write all 5s to the part, see if they come back, write all A's. Those are alternating bit patterns, 5 and A. It's only 4 bits. Remember, it's only 4 bits that you're testing. It's not an 8-bit part. And it does some other ones too. So it does that over and over again and writes them to the part and then reads them back from the part and see if they're the same. All right. So let me plug the Uno into the USB, and then when you run this thing, you just open up the serial monitor here, and you can see it going. So it's writing zeros. Yeah, let me pause it for a second. Write zeros, and then 5s, and then A's, and then F's, and then 1, 2, 4, 8. And it just does that over and over again. So yeah, the parts check out just fine. So that's not the issue, but that's what I did. That's what I did yesterday all day long. Was get this all going, and not all day long, but in my spare time when I get to play electronics, that's what I was doing. Yeah, you can find this. You just search the internet for 2114 memory chip tester, and this will pop up. You'll find it. Well, I guess they're good. So they're going to go back in the in the machine here and pop them back in and try to figure out what else is wrong. All right. So I have the logic analyzer hooked up, And so I'll show it here. So the top trace isn't used. Then I have the clock that gets divided down into a 16 millisecond pulse. And let me show you that on schematic here. I don't know if you remember it, but there's a counter here, a 4060 counter, and it takes the 2 megahertz clock and divides it down to 16 megahertz, and then it runs this down counter, and this down counter will count down, and if it doesn't get a signal, it'll count down all the way and create a reset. And you can see that here, that after 10 pulses or maybe 9 pulses of the counter, the reset signal will fire, which is at the very, very bottom. So every 10 counts, you get a reset. And then when the reset goes high, then the microprocessor starts to run. There's a line that's analog clock. It's a clock that's sent out to the analog board. That's quiet. And then there's the chip select of the 8255. So if you're going to scan the front panel, you're going to be constantly talking to that 8255. So I'm monitoring the chip select of the 8255. So it's definitely being talked to. Let me zoom in here so you can see that. You can see that the chip select of the 8255 is going. All right. Then the output of the 8255 will be a serial clock and data, which on the logic analyzer here is clock and data. Those are quiet. And then you'll send serial data, and then you'll also be strobing the segments, the seven segments of the display. So I'm looking at segment A, and it's quiet too. All right, so this is kind of the normal state of affairs. Let me cycle the power on it, and you can see everything will go dead. Let me power it back up, and ooh, look at that. So I am getting some interesting things here on the front panel, and so I am getting some clock and data. The analog clock is firing once in a while. It's trying. It's definitely trying. But it's trying badly. Yeah. It's definitely trying badly. Let's push a button here. Let's push DC volts. Oh, look at that. It changed. Oh, wow, it changed. Let's hit a range here. Yeah. Oh, look at that. When I hit the button, things do change. DC volt. So it's close to working. It is, and now it just died. Oh, now it came back again. Interesting. So this is the very best it's ever done. As soon as I hook up the camera so I can video it, I've been working on this thing all day, and it hasn't done this. And suddenly it's getting a little better. But don't ask me why. Do not ask me why. Okay, and I'm going to dare to turn it on and off again because it won't come back. Okay, I turned it off. I turned it back on, and nothing. And you can see the chip selected, the 8255 looks funny. Everything looks funny. I'll turn it on and off again, and not much is going on. On and off again. Not much is going on. On and off again. Yeah, see, it's weird. And there we go again, back to the normal state of affairs, where it just kind of doesn't do much at all. So why would it sometimes catch? Why would it sometimes want to try to do stuff, but most of the time I mean, hours, for hours. It doesn't do anything at all. Yeah, I don't quite understand yet. Some people may want to say, oh, it's your front panel's bad. No, the front panel's fine. I can disconnect the connector on the front panel and it behaves exactly the same way. There's just no clock and data or anything else of interest going on to the front panel. I've considered making a little Arduino board just to drive the front panel and prove to myself that the front panel works just fine, but I talked myself out of that, saying, no, it's not that. There's something else somewhere else. I don't know. Anyway, that's where I am now.